Welcome to this explainer on the water cycle. If you're prepping for a middle school science test or you just want to know how our planet works, you are in exactly the right place. We're going to dive straight into the incredible, continuous journey of Earth's ultimate recycling system. All right, let me hit you with a question that might sound a little crazy at first. Are you drinking the exact same water as the ancient Romans or the ancient Greeks? It sounds impossible, right? But it is absolutely true. Today, we're unpacking the science behind how you're sharing your water with ancient history. You are literally drinking the past. Actually, it goes back way further than the Romans. Try 4 billion years. Yeah, our Earth has been recycling the exact same water for over 4 billion years. We don't get shipments of new water from space. Every drop of rain, every glass of water, and every snowball you throw is made of the exact same matter that's been swirling around this globe since the Earth was young. So here is our roadmap for today. We'll cover Earth's ancient recycling system, how water enters the atmosphere, cooling down and forming clouds, falling back to Earth, and finally, your daily water usage. Let's jump right into Section 1, Earth's ancient recycling system. This right here is the big picture. Water continuously moves through a massive, never-ending loop. It flows between our rivers, lakes, oceans, the atmosphere, and the land. The water is in a state of constant motion, changing forms and shifting locations, but it never actually leaves the system. That's exactly why we call it a cycle. And here is why this matters to you personally. It's not just about rivers and clouds. Your own body is made up of at least 60% water. Without this cycle constantly refreshing and moving water around the globe, life as we know it, including you and me, simply wouldn't exist. You are literally a walking, talking piece of the water cycle. Moving on to Section 2. Water enters the atmosphere. All right, let's grab some essential science vocabulary here. Water moves up into the sky primarily through evaporation. That's when liquid water in oceans and lakes turns into an invisible gas called water vapor. But there's a second, really awesome way this happens called transpiration. This is when water evaporates directly from plants. Yep, trees and grass are constantly breathing out water vapor right into the air around us. If we zoom way in, we can see the particle theory at work. First, energy from the sun heats up the liquid water, and those tiny particles gain energy. Because they're supercharged, they start moving super fast. Eventually, they get so energized, they literally break free from the forces holding them together as a liquid. They turn into a gas, that water vapor we just talked about, and rise right up into the atmosphere. Which brings us to Section 3, cooling down and forming clouds. So what happens to all that high-energy vapor once it's up in the sky? Well, the environment changes. It gets much colder up there, and this temperature drop triggers condensation. Condensation is just the exact opposite of evaporation. That invisible water vapor cools down and changes back into tiny little droplets of liquid water in the air. Let's check back in on our microscopic particles to see how this works. As that vapor hits the cooler atmosphere, those fast-moving particles lose their heat energy. They basically run out of steam, slow down, and start clumping back together into liquid droplets. And when millions and billions of these little droplets group together, you get the clouds you see being pushed around by air currents. The coolest part is you don't have to be thousands of feet up to see this. You can spot these concepts in everyday life. Notice the high-energy steam rising off a hot lake in the morning? That's evaporation in action. Or when you breathe warm, vapor-filled air onto a cold window, those particles lose energy and fog up the glass with tiny water droplets. That's condensation. It's literally the exact same science making clouds. Up next is Section 4, falling back to Earth. So, up in the clouds, condensation is continuously happening, but eventually those tiny cloud droplets merge, they grow, and they become far too heavy for the air currents to hold them up anymore. That is when gravity takes over. When gravity takes over, those heavy droplets fall back down in a process called precipitation. This is our final major vocabulary word for the cycle. Precipitation is basically the delivery system bringing water right back to our oceans, the land, and our underground groundwater systems. And keep in mind, precipitation isn't just rain. Depending on how cold the air is on the way down, it can freeze and hit the ground as snow, hail, or sleet. So whether you're splashing in a warm summer puddle or having a snowball fight, you're directly interacting with the precipitation phase. And that brings us to our final stop, Section 5, your daily water usage. Before we completely wrap up, let's do a quick mental check. You should now be totally confident using words like evaporation, transpiration, condensation, and precipitation. But more importantly, you know the hidden world driving them. You know how tiny particles gaining energy from the sun and losing it in the cold air act as the invisible engine for this entire 4 billion-year-old system. Now, the cycle never stops, but water can pause its journey. Whether that ancient water is temporarily locked up in a massive freezing glacier, slowly filtering through dark underground streams, or pouring freely right out of your kitchen tap, it is all part of the exact same continuous loop. So knowing that every single drop is ancient, recycled history, I want to leave you with this final thought directly from our source material. Think about all the water you personally use today. You woke up, maybe brushed your teeth, took a shower, grabbed a glass of water. How much do you think you actually use in a single day? And now that you know how ancient and precious this recycling system really is, how can you help protect it? It's definitely something to think about the next time you turn on the tap.